Alright, today we're going to talk about adding and subtracting polynomials. So we're going to actually just jump right in to our first example. Example 1. We're just going to add and subtract. So our first portion, I'm going to look at least 3 problems here. The first one's going to have 15m to the third plus 6m to the 2 to the second plus 2m to the third. Now to add these, we're going to look at, do they have the same variable, and are the variables raised to the same power? So in this first term, in fact in all terms, they have an m, so they have the same variable. This first term has an m to the third, and I see one other term with an m to the third. And then this last term has an m squared. So what that means is we can combine the terms with the same variable, with the same exponents. We can combine like terms. So let's combine 15m to the third plus 2m to the third. We're just going to add the numbers that are in front of m. 15 plus 2 is 17, and then we're just going to write m to the third right after it. And there's nothing to combine with the 6m squared, so we're just going to bring it right down. So we're going to have 17m to the third plus 6m squared, and that's our answer. Let's look at another one. We're going to have 3x squared plus 5 minus 7x squared plus 12. Well, I'm going to circle the liked terms. So we've got 3x squared and a minus 7x squared are like terms. We also have a 5 that's a constant. It has no x's. And we have another constant, 12. So no variables there. We can combine things with like terms. So 3x squared minus 7x squared, we just go 3 minus 7. And that's going to give us a negative 4x squared. And then we can combine 5 and 12. Well, 5 plus 12 is 17. So we're going to end up with negative 4x squared plus 17. And that one we're all done with. Let's look at a couple where we also subtract. So these ones just involve adding. Let's look at some where we subtract. We'll call this 1c. We're going to have 9y to the 5th minus 4y to the 5th plus 5y to the 5th plus 10y to the 5th. Now, all of these terms have the same variable. Excuse me. I actually meant to make this a 5x to the 5th. So not all the terms have the same variable, but 3 of them do. 9y to the 5th minus 4y to the 5th and 10y to the 5th, while this 5x to the 5th is our oddball out. So we're going to go 9 minus 4, which is 5, and then we're going to add 10 to that to get 15y to the power of 5 plus 5x to the power of 5, because there was nothing to combine with that. And we're all done there. All we do is add and subtract the coefficients, the numbers in front of the like variables. So this is what this example was, adding monomials or subtracting them. Now let's look at what we would do if we have to add or subtract a polynomial. So example 2A, we're going to look at 2x to the 2 minus x, and we're going to add to that x squared plus 3x minus 1. So what we're going to do is we are going to regroup this with like terms. So we're going to regroup any of our x squared terms to be next to each other, any of our x terms to be next to each other, and then any constants to be with each other. So we're going to rewrite this as 2x squared plus x squared minus x plus 3x minus 1. Well, in red, our 2x squared is getting another x squared added to it, and there's, just as a reminder, always a secret 1 that's out in front of there when we don't see any other numbers. So 2x squared and another x squared is going to make 3x squared. A negative 1x squared plus 3x squared is going to give us a plus, and that's not x squared, I'm sorry. In blue it's no x squared, it's just a single x. So we're going to get plus 2x, and then there's nothing to combine with our 1, so we just bring that down. So our answer is 3x squared plus 2x minus 1. So let's do one more together, and then we'll look at subtracting polynomials. So 2b, we'll take 4b to the 5th plus 8b. We're going to add to that 3b to the 5th plus 6b minus 7b to the 5th plus b. So the first thing we have to do is we need to, in that second set of parentheses, combine like terms. So we've got two terms that are 3b, or have a b to the 5th, and then we've got two terms that are just a single b. So let's combine them before we do anything else. If we combine 3b to the 5th with a minus 7b to the 5th, we're going to get negative 4b to the 5th. And if we combine 6b with 1b, we're going to get a plus 7b. And then we can bring down the rest of our problem. 4b to the 5th plus 8b, and we're going to add what we've got going on there as well. So now we can look at the two parts and see, well, what like terms do we have? Well, we've got a 4b to the 5th and a minus 4b to the 5th. And then we've got an 8b and a 7b. So let's combine 4b to the 5th minus 4b to the 5th. Well, when we minus 4b to the 5th from 4b to the 5th, that's 0. So in blue, we're just going to get 0. And in our red parts, 8b plus 7b is 15b. If we were to add a 0 in 15b, we would just get 15b back. So now let's look at what would we do if we're going to subtract polynomials. So this is example 3. We're going to take 2x squared plus 6, and we're going to subtract 4x squared from that. So in this case, what we're going to do is we're going to distribute the negative, the minus sign, to what we have in the parentheses after it, and we're going to rewrite it as 2x squared plus 6. We're going to change that minus to a plus, and then in the parentheses, a negative times a positive 4x is going to make a negative 4x squared. Now, this is just an addition problem, like we just looked at. So we're going to combine like terms. We've got 2x squareds, and we've got minus 4x squareds, and then we have a 6. So let's combine the like terms. 2x squared minus 4x squared is going to give us a negative 2x squared. And there's nothing to combine the 6 with, so we just bring down a plus 6. All done with that problem. So let's look at one more. This will be 3b, and then we'll have one final kind of application example. So we're going to subtract 3x squared minus 2x plus 8. From that, we'll subtract x squared minus 4. So we are going to start by distributing the minus to the x squared minus 4, and we're going to rewrite our problem. We're going to have 3x squared minus 2x plus 8. We did not have to distribute anything there. We're going to change that minus to a plus, and then we're going to have a negative x squared. And if we multiply the negative times the minus 4, we're going to get a plus 4. Now we can start combining like terms. So I'm going to circle all my x squared terms here in blue. I'm going to circle all my simply just an x term in green. And any constants I'm going to circle in red. So now let's combine the things that have the same color circle around them. If I have 3x squared and I add a negative x squared to that, that's going to make a, well, 3x squared, it's like 3x squared minus x squared. We're going to have 2x squared. Now I have nothing to combine with this minus 2x, so I'm just going to bring that down. And then 8 plus 4 is going to give us a plus 12. So 2x squared minus 2x plus 12 is our answer to that. All right, let's look at our last example for this lesson. And this one is a word problem. So it's example 4. We have the profits of two different manufacturing plants can be modeled as shown, and I'm going to give you the equations. In a second, but I'm going to give you some more information first, where x is the number of units produced at each plant. So I'm going to give you the equations now before I write any more of this problem. So the equations, we've got two plants. We've got an eastern plant. It has the equation negative 0.03 x squared plus 25x minus 1,500. Then we also have a southern plant. Where that expression, or that polynomial, is negative 0.02 x squared plus 2x minus 1,700. Now I can give you the very last bit of information we need before we can solve this problem. So what we need to do is write a polynomial that represents the difference of the profits at the eastern plant and the profits at the southern plant. So what we need to know is first difference. Difference means we're going to subtract. Now when they say difference of the profits of the eastern plant and southern plant, this means we write the eastern plant information first and the southern plant information second. So we're going to have in parentheses a negative 0.03 x squared plus 25x minus 1,500. Difference means to subtract negative 0.02 x squared plus 2x minus 1,700. So we're going to subtract those two polynomials. The first thing we need to do, distribute this minus sign to everything in the parentheses that follows it. All that means is we're going to rewrite it as a plus and then change the signs of everything that's in the parentheses. So we'll make the negative 0.02 to a positive 0.02 x squared. Change plus 2x to minus 2x. Change minus 1,700 to plus 1,700. And then we can just rewrite that first half. Alright, now I'm going to go and circle my like terms. I've got x squareds here in blue. I've got my x, just x to the first terms in red. And I've got my constants here in green. So let's combine. Negative 0.03 plus 0.02 gives me a negative 0.01 x squared. 25x minus 2x is going to give me plus, let me change that color quick, plus 23x, and then negative 1,500 plus 1,700 is going to give us a plus 200. So our expression for the difference of these two plants is going to be negative 0.01 x squared plus 23x plus 200. And that wraps up our lesson on adding and subtracting polynomials.